Next, we shall discuss about grammar. We have seen that a language will be defined over some alphabet, and using the symbols in the alphabet, we can form infinite number of strings. But according to the language, only some strings are valid. So they are the valid strings for the language. Now, what is a grammar for the language? For every language, there will be a grammar which consists of a set of rules which define how to form each valid string of the language. So, by using the grammar rules, we should be able to generate each and every valid string of the language. A grammar is generally represented by a four-tuple G equals VTPS, where V is the set of variables, T is the set of terminals, P is the set of production rules, and S is the start symbol. Here we have a language set of all strings of length 2. So for this language, there will be a grammar represented by the four-tuple VTPS. Here the alphabet set of the language will become the terminal set of the grammar. So the terminal set consists of A and B. In addition to the terminal symbols, grammar makes use of some symbols that can be replaced. They are called non-terminal symbols or variable. Here we are using two variables, S and X. One of these variables is the start symbol. Then we have the production rules which actually define how to form each valid string of the language. Here we have the production rules. S derives XX, then X derives A or X derives B. Using this grammar, we should be able to generate each valid string of the language. So to derive AA, we can start from the start symbol. We can use the first production rule S derive XX. We can replace the first X in the next step with A, and in the next step we can replace the next X with A, then we can derive AA. Similarly, to derive AB, start from the start symbol, S derive XX, replace X with A, then replace X with B. Now to derive BA, start from the start symbol, S derive XX, replace X with B, then replace this X with A. Now to derive BP, S derives XX, replace X with B, then replace X with B. So we can derive all the four valid strings of this language using the grammar. So this is the grammar for this language, or this is the generator of the entire language. Similarly, for every language, there will be a grammar. Using the grammar rules, we should be able to generate each and every valid string of that language, and hence the grammar is called the generator of a language. Every language has a corresponding grammar. So like we classified the languages into different classes, we can classify the different grammars into different groups. The set of grammars which generate the regular languages can be put under a group called regular grammar set. Then we have a context-free grammar set, a context-sensitive grammar set, and an unrestricted grammar set. Here we can see every regular grammar is a context-free grammar, every context-free grammar is a context-sensitive grammar, and every context-sensitive grammar is an unrestricted grammar. Now, a language generated by a regular grammar is always a regular language. Then, a language generated by a context-free grammar is always a context-free language. And a context-free language can be sometimes regular too. So we can say a language generated by a context-free grammar is always a context-free language, and sometimes it can be a regular language too. Similarly, a language generated by a context-sensitive grammar is always a context-sensitive language. Sometimes it can be a context-free language, and sometimes even it can be a regular language too. And the same here.